Welcome you all to the video laboratory series. I am Professor Amit Kumar Patil from Department of Electronics and Communication Engineering, School of Engineering Sciences, MIT Art Design and Technology University, Pune. Today we'll perform the experiment of the subject Digital Signal Processing Laboratory. The title of the experiment is to verify sampling theorem. So let us come to the experiment. Okay, so let's come to the program for the verification of sampling theorem. Okay. So here we will do the programming in the 4 steps. First step, we will generate the continuous time signal. Okay. And then in the second step, we will generate a signal when the sampling frequency is less than twice the maximum frequency. Then next case, sampling frequency equal to twice the maximum frequency, and last case, sampling frequency is greater than twice the maximum frequency of the signal. Okay. So let us come to the first graph. Okay. Suppose I want to plot a continuous time signal. Okay, so the command that I will give simple is x equal to cos 2 pi ft. This is the command. Okay, whenever you want to plot any signal, sinusoidal, cosinusoidal signal, simple cos omega t or sin omega t. So what is sin omega t? Sin 2 pi ft. Or what is cos omega t? Cos 2 pi ft. Okay, but in MATLAB while writing the code here we cannot write directly 2 pi ft. What do we have to write? Cos 2 multiplied by pi multiplied by f. So instead of f, here we will take fm. Okay, fm dot t. Okay, fm dot t. But here first we have to assume the values. We have to assume what is the value of fm, what is the value of t. Okay, so t we will assume, we will take the time period. Okay, from a particular range, from negative range to positive range, we will take different values of the time period. Suppose I want to take from a vast range, I want to take, so I will take from minus 100 to plus 100. Okay, but if we directly type minus 100 colon plus 100, it will take a gap of 1111. Suppose you want more number of values, na? We will get a proper graph. When we will get proper graph, when we will take more number of samples. Okay, so here I will take 0.01. Between each sample there will be a gap of 0.01 colon 100. Okay, this much gap we will take so that a proper signal will be obtained. Okay, so time period minus 100 to plus 100 at an interval of 0.01. Okay, and now fm we have to assume maximum frequency of the signal. So suppose we are assuming it as these values, we have to assume, and t we can assume any value. A vast range we will take so that more number of samples will be there, so that we will get a proper graph. fm we can take 0.02. Okay, this also we can assume any value. So these two values I have assumed. Okay, t and fm, and by using this we will get a graph of a continuous time signal. Okay, but before plotting the graph we will give the labeling and title to the signal. Okay, so x label, and here we have to write in x-axis we have taken time. Okay, x-axis we have taken time, and y-axis labeling, so y label, and here you have to give on y-axis we are taking amplitude. Okay, y-axis there will be amplitude, and finally we have to give the title to the graph. So title we have to write, this is what, this is a continuous time signal. Okay, this is a continuous time signal, or if you want continuous time signal. Okay, this is the title. Okay, y label is amplitude, or you can also write like this. Instead of amplitude we can also write, for better understanding, this is xt. Okay, x-axis is what, time, y label, y-axis is this. Okay, so this will plot the graph. and also we can decide on which position we want the graph. Okay, for plotting the graph we have to write the command first. Okay, so what is the command to plot the graph? Simple, plot x-axis versus y-axis. And x-axis what we have taken, time t. On y-axis we are taking amplitude. What is amplitude? X. Okay, so plot t comma x. Okay, and now if you want certain position for this graph, so what is the code for that? The code is subplot. Okay, so we want, suppose we want graph like this, first, then side by it second, then below it third, then fourth. So we will take a 2 cross 2 matrix, 2 comma 2. It means there will be 2 rows and 2 columns, and at the first position we want this graph. So here we have to put 1. Okay, so this is the code for the continuous time signal. So here we will get continuous time signal at the first position. Okay, so now what I will do, from here we have to run the graph. So click on the run. When you run it, it will ask to save. So it is the sampling experiment. Okay, sampling experiment. So here we will save it, and after saving, here you can see this is the graph, continuous time signal t versus x of. Now here we will plot the second graph, and below it third graph, and finally here fourth graph. Okay, so 4 graphs we are going to plot. So now let us come to the second part. Okay, so in second part, now we will go for the next case. Okay, sampling frequency is less than twice the maximum frequency of the signal. Okay, so for plotting the graph, simply I will write, now here we have taken x, so now I will take x1. X1 is equals to cos or sine, anyone you can take. Okay, 2 multiplied by pi multiplied by fm multiplied by t1. What is t1? N1 by fs1. So n1 divided by fs1. Okay, but before plotting it, we have to assume the value of n1 and fs1. Okay, what is fs1? Fs1 is the sampling frequency. What is n1? N1 is the number of samples. Okay, so fs1 sampling frequency I will take, but this we are plotting for sampling frequency less than twice the maximum frequency. So maximum frequency is 0.02, its twice will be 0.04. So we have to take a value which is less than 0.04. Okay, so what I will take? I will take 0.02. It is less than 0.04. Okay, and also we have to assume the value of n1. So what is the value of n1? N1 we can take any range of the samples. Okay, n1 we can assume any range. Okay, suppose I take the range from -2 to 2. Okay, this range I have taken from -2 to 2. This range I have taken. Okay, now we have to plot this. Now what we are going to do, we are converting a continuous time signal into a discrete time signal. Okay, so here we have to plot a discrete time signal. What is the command to plot the discrete time signal? Stamp. Okay, plot we use for continuous time. For discrete time we use stamp. Stamp horizontal axis versus vertical axis. Okay, so what is the horizontal axis now? Horizontal axis will be n1, number of samples. Okay, that we have taken. Vertical axis will be amplitude. Amplitude is calculated by x1. Okay, this will be the stamp. Before plotting the signal, we will decide the position, on which position you want the graph. So for that you have to write the command subplot. Okay, subplot we have to write 2 comma 2. Okay, 2 row 2 column, but now I want it in second position, so comma 2 you have to write. 2 comma 2 comma 2. Okay, so this we have done, and after this x label, y label, and title. Okay, so x label. Now this is what we have taken on horizontal axis, number of samples n1. Okay, so you can write n1 or number of samples. Y label, On y level what we are taking? We are taking the amplitude. Okay, so x1 or x1n, whatever you want, you can write. Okay, so this we have done, and after this we have to give the title. So what is the title of the graph? This is the plot. First case, sampling frequency is less than twice the maximum frequency case. This is the title of the graph. Okay, so now what I will do, we will run this program till now, whatever we have done. So come here and run the program. So here you can see, now here you can see that sampling frequency is less than twice the maximum frequency. The signal is not sampled properly, means we cannot recover the original signal. Here you can see only a few samples we have obtained, and if we join them we will not get a continuous time graph. Okay, so this is the undersampling case. Now come to the next case. So next case is sampling frequency exactly equal to the twice the maximum frequency. Now here if you want to plot the graph, we will to write the command. So x2 is equals to cos 2 multiplied by pi multiplied by fm multiplied by t2. T2 is what? N2 divided by fs2. Okay, T2 is N2 divided by fs2. So now here we have to assume the value of sampling frequency again and N2 again. In each case we have to assume this value. So fs2. Okay, now here we are going for the case sampling frequency is exactly equal to twice the maximum frequency of the signal. Okay, so what is the maximum frequency? 0.02. So twice will be 0.04. Okay, 0.04. Okay, understood this? And also we have to assume the value of n2. So n2 we are assuming it from -4 to 4. Okay, this we assume the value of n2. N2 and fs2 we have to assume in each case for plotting the graph. Okay, now for plotting the graph, first we will decide the position, on which position we want. So use the command subplot 2 comma 2 comma we want third position. So 2 comma 2 comma 3. Oh, and then for plotting the graph of this continuous time signal, stamp horizontal axis versus vertical axis. Horizontal is n2 comma vertical axis is x2. Okay, and then again x label, y label, title. Okay, so again these three lines will come. Now here what I will do, x label will be n2, y label will be x2, and fs will be equal to twice the maximum frequency. Okay, now I will run this part of the graph. So if you run it, here you can see this is the case fs is equal to twice of fm. Some samples we have got, but the sampling is better than the first case. Okay, but even not more better. Okay, more better we will get in the last case when we will take large number of sampling frequency will be greater than maximum, twice the maximum frequency. Okay, this is the third case, and now we will come to the last case. So for last case what we have to do, x1 x2 already we have taken, so we will take now x3. So x3 is equals to cos 2 multiplied by x3 is equals to cos 2 multiplied by 2 pi fm multiplied by t3. T3 is what? N3 divided by fs3. Okay, N3 divided by fs3. Now here we have to again assume the case of values of n3 and fs3. fs3 should be greater than twice the maximum. What is fm? fm we have assumed 0.02. And fm we have assumed 0.02. Okay, fm is 0.02. So greater than twice the fm. So greater than 0.04, any value we can assume. Any value we can assume that should be greater than 0.04. So suppose I am assuming here fs3 is equals to 0.5. Okay, 0.5 is greater than 0.04. Okay, and similarly we have to assume n3. n3 is the number of samples. So number of samples we can assume any range. Suppose I assume minus 50 to plus 50. This we assume. Okay, minus 50 to plus 50. Generally what we are doing, we are multiplying this value. Here was 0.04. So when you multiply it by 100, minus 4 we got. Okay. Generally how I am assuming, I am multiplying this value by 100. 0.5 multiplied by 100. Okay. Okay. In this way I am assuming. You can assume your way also. Okay. In this way, when you do, you will get the proper graph of the signal. Okay. Now again, we want to plot. So first decide the position. For deciding the position, subplot. So subplot is 2, 2, position will be 4th. And finally plot the graph. So stamp n3, x3. Okay. And again, x label, y label and title. So this we have to give. So here we have to put x label. Here now it will be n3. Y label will be x3. And title sampling frequency is greater than twice the maximum frequency. Okay. So this we have done. In this way, step by step, and 4 times we have already run the program. Now we will check the final output. So when you run it, here you will see the proper graph is obtained. This is the last case. So whenever you are taking sampling frequency greater than twice the maximum frequency, you will get the exact proper signal will be properly sampled. Okay, signal will be properly sampled. Okay, and also it can be reconstructed. Okay, so in this way we have to go for the programming for the title verification of sampling.